This is a location-based AR escape game. Players walk into this actual physical space and they see a gate, some wiring and some steam gauges, all locked to specific spots in the real world. And here's the thing, this entire experience, we're going to build it in few minutes from scanning the location, placing the content and testing it in AR. Hello, my name is Pavel and I'm a co-founder here in Ogio. Today I will show you how I created a location-based AR escape game in a few minutes using Ogio. I'm assuming you've already installed Unity and the Ogio plugin. If not, check the setup video I'll link in the description. You have the scanning app on your device and you're comfortable with basic Unity navigation. If you're all set up, let's jump in. Okay. First of all, we need to capture the physical location. I have a detailed scanning tutorial linked below, but let me show you the basics of scanning because it's important to understand what makes a good scan. So I'm using the Ogio scanning app. While scanning, I have to move slowly and methodically. I'm making sure to capture the walls and the major surfaces, key architectural features like doorways and corners, and any areas where I know I want to place content. The key is smooth and deliberate movement, not too fast. Make sure you have good lighting. Also try to cover the entire play area from multiple angles. Put yourself in your user's shoes and scan the location from the perspectives they are most likely to use. Now we're going to upload the Ogio anchor to the cloud. We can try to resolve the anchor and test the quality of the scan. And once we're satisfied with how quickly it resolves, we can then approve the anchor and upload it to the cloud. Alright, scan's done. Now I'm going to let Ogio process it and upload it to the cloud. This usually takes a minute or two depending on the size of your space. What I'm doing here is resolving the location, which is relevant for locations with multiple anchors. It places the anchors relative to each other and uploads the relative positions to Ogio Cloud. You can then work with those relative positions in Unity. Okay, with our scan processed, the next step is to create a new experience and make sure we assign this new location to it. I've opened the experience on my phone and letting it localize by looking around. It has found the anchor. Now I clicked the anchor gizmo and created a new object, named it gate, and placed it somewhere in the scene. Alright, that's all we need to do on device, and let's continue in Unity Editor. I've already got a Unity project set up with Ogio plugin installed. If you haven't done that yet, pause this video and watch the setup tutorial first. So I've opened the Ogio plugin in Unity and logged in using the API key that you can find in the Ogio CMS. I will select the experience we created earlier and I will click Download Meshes. This will download the scans from the cloud that we uploaded earlier. I have also imported the experience into Unity. I'm also going to enable the mesh visualization so we can see the mesh in our scene. And here it is, the gate, the corner, everything. This is your canvas. This is where you're going to place the AR content. Okay, before we start throwing content into the scene, let me explain how Ogio thinks about AR objects. In Ogio, everything you want to place in AR is an Ogio object. Think of it as a container. Inside that container, you put your actual content, your models, your animations, whatever. But here's the important part. We also create something called a placeholder object. This is a simple shape, usually just a cube or a sphere, that represents your content in the scanning app. Why? Because when you're testing it in AR, you don't want to load heavy 3D models just to adjust positions. The placeholder gives you a lightweight visual reference you can move around in real time. Okay, let me show you how I do it. So I'm going to use the audio object that we created earlier, and I'm going to put my content as a child of that object. I will make sure my content's transform is all zeroed out. I will now drag the audio object into place and make sure it fits with my scan. I will move the camera around the scene and look at it from all the different angles to make sure my content is where it needs to be. Here it is, the perfect position. Now let me show you how I create a placeholder object. To create a new placeholder object, I use the context menu here, I select audio and add a new placeholder object. I will name the object gate placeholder. I will select cube as its model representation. I will assign the experience and the appropriate audio object. I also need to make sure that gizmos are visible in the scene. Now I'm going to scale this placeholder box to roughly match the bounds of my gate. It doesn't have to be perfect, it just needs to give me a visual reference in AR. When I open this location in a scanning app later, I'll see this placeholder box. Instead of the full gate model, I can tap it, move it, rotate it, and work with my experience with all of the context I need. And perfect, that's first placeholder done, and let's move on to the rest of the content. So now I'm going to do all of this again for all of the content I have ready in my scene. So you see me here placing the placeholder for the steam gauge box, and I will do that for the wiring, for the tubes, and for the safe as well. And there we have it. This is our complete escape game scene. All these assets are positioned exactly where I want them in the physical space. If I turn off mesh visualization, you can see just the 3D content. Turn it back on, and you see how everything relates to the actual physical environment. Alright, let's see how this looks in the real space. Also, please don't forget to upload the changes through the audio plugin before you build. And here they are. All of the placeholders appearing exactly where we placed them in Unity. And if I tap the placeholder, I can change its position, rotation, or scale. And here's the beautiful part. All these changes are immediately saved, and if I close the app and come back to my build, I'll see my updated positions right away. Now let's come back to Unity and let's build the app. Since we're doing an iOS build, we also need to finish building the app using Xcode. Alright, so here's what the players actually see when they launch the final escape game. Instead of placeholder boxes, they see the complete game with high quality content, this ornate gate, the steampunk boxes and wires, and all the interactive puzzle elements. Okay, so here's the actual game loop. Players will walk up to the gate and see two things: a locked safe on the ground and an input box on the gate itself. They'll realize they need a code for that input box to open the safe. So they'll need to find a steam gauge box we placed nearby. They use the hint on that box to figure out the combination. Then they come back to the gate and input the code into the box. And that's what unlocks the safe on the ground. And this is why real-world alignment is so important. Because everything we positioned in Unity is exactly where we want it, the whole loop feels right. Players walk up to the gate, they see the safe and the puzzle elements align with the real architectural features. The entire experience feels integrated into the physical space. This is the power of site-specific AR design. We're not just dropping content somewhere, but we're designing for the specific location. And Audio is here to make that process simple and fun. So we built an escape game, but this same workflow works for anything location-based. Be it interactive museum exhibits where artifacts come to life, bouldering guides showing the correct route, site-specific art installations, industrial training scenarios mapped to the real equipment. The workflow is always the same: scan, place, test, refine. Alright, that's the complete workflow for building location-based AR escape game. To dive deeper, check out our docs, link in the description. Join our Discord community, linked below, or watch the rest of our tutorial series. The tools for building spatial web have arrived. We can't wait what you build with them. Thank you for watching.